for the function f of x equals x to the fourth minus 5x cubed minus 17x squared plus 15x plus 42, find the rational zeros and then the other zeros. That is, solve the function set to 0. So to begin, oh my. I'm looking at this function x to the fourth minus 5x cubed minus 17x squared plus 15x plus 42. And I want to think about it being set to 0, which means I need to factor it. And the first thing I'm going to do is look at what are my possible zeros. And to do that, I think about the number in front of the x to the fourth term. And it's a 1, so I'm thinking about factors of my constant, which is positive 42. So factors of 42 over those factors of 1 here. And remember, that's got to be plus or minus. And that's going to give me plus or minus, since it's just over 1, then I can just list the factors of 42, and those are 1, 2, 3, 4 doesn't work, 5, no, 6 times 7, and then 3 times 14, 2 times 21, and 1 times 42. So I can list all those factors there. Of course, I'm going to start with the easy ones, which are plus or minus 1. So starting with a positive 1, look at all the coefficients for my polynomial. I have a 1 minus 5 minus 17 plus 15 plus 42. Remember, this is synthetic division, and it's a quick way to check if a factor works for a particular polynomial just by looking at all the coefficients. So first thing you do is bring down that 1, multiply 1 times the number in your box, which is a 1, and so that gives me a 1. Add it to negative 5, so I get negative 4. Multiply that negative 4 times 1, so I get negative 4. Negative 17 and a negative 4 will give me a negative 21. Multiply by 1 and then write it up here, negative 21. That's going to give me a negative 6 times a 1. That's going to be negative 6. That's not giving me 0. I can see that right away. Okay. So the next number that I'll try is a negative 1. The very next thing in my list. Since I have positive or negative 1, I'll try negative 1 next. 1 minus 5 minus 17 plus 15 plus 42. Bring down the 1. 1 times negative 1, so I get negative 1. This gives me a negative 6 when I add them. Negative times negative will be a positive. So this is going to be negative 11. Multiply those, I get a positive 11. 15 plus 11, 26. Times a negative 1 will be negative 26. This one's obviously not giving me a 0. So the next thing in my list is a positive 2. So I'll try a positive 2. Bring down the 1 times 2 will give me a 2. That'll give me a negative 3 times 2 will be a negative 6. When I add those, negative 23 times 2 will be a positive or negative 46 minus 15, negative 31, and multiply by 2. That's not going to work either because I get a negative 62. So we'll try negative 2. Bring down that 1, multiply by negative 2. So I have a negative 2, add those, I get negative 7. Multiply by that negative 2 again, I get a positive 14. Add those, I get a negative 3. Negative 3 times negative 2 is a positive 6. that gives me a 21, and then when I multiply by negative 21 or negative 2, I get negative 42, and those two add up to 0. So at this point, I know some things. I know that this factor, this is my c, and if I put it in the form x minus c, then it's x minus a negative 2. So I'm just going to write down x plus 2 for that factor that I know. And the rest of the factors come from this line right here. And I just need to drop down 1 degree from my original polynomial. My original was x to the 4th, so this one will be x to the 3rd. And since I have a 1 there, it'll just be a 1x to the 3rd, or just x to the 3rd. And then drop down 1 degree for each of the following terms. So negative 7x squared minus 3x plus 21. So I have it in its partially factored form. I see 4 terms here, so I'm thinking maybe factor by grouping will work. So I'm going to look at the first pair and the second pair of terms. For the first pair of terms, I can factor out an x squared, and I have left x minus 7. For the second pair, it looks like a negative 3, and that'll be x minus 7 as well. And my factors then are x squared minus 3 times the quantity x minus 7 for this 4-term polynomial here. And then I have to bring down my x plus 2, which I had already found. So it's still not in the form of linear factors because I see an x squared here. So what I want to do is off to the side think about x squared minus 3 and set that to 0. So I'll add the 3 to both sides. Just like we would for that entire polynomial, you can set any factor to 0. In this case, I'm setting it to 0 to find my factor parts, and that's okay. It'll work out just as well. So I have x squared equals 3, and then take the square root of both sides. And remember, when you introduce it and take the square root on both sides, you have to put a positive or negative, because there are 2 ways that you could multiply a number times itself and get a positive 3. So we're left with x equals the positive or the negative square root of 3. Now, since I know my x's, remember that's just like over here, I knew my x was a negative 2. I can put it into the form x minus c, where my c's are coming from the right-hand side here. And so one of them is going to be, we have x plus 2 already, and then one of those factors is x minus the square root of 3, and the other is x plus the square root of 3, and then my last factor from the list, x minus 7. So I have the polynomial in its factored form, which I generally want to see, and then I need to solve it. So I need to know what are the solutions for this polynomial. If I set each factor to 0, 2 of them I already know because I already had them set to 0, and that's the plus or minus square root of 3. But I do also know that an x for this factor would be a negative 2, and I can see that here as well. And then I have positive or negative square root of 3. And then from this last factor, if I set that to 0, x minus 7 equals 0, I can move the 7 over and it'll be x is a positive 7. So those are my 4 solutions to this polynomial, which has to be 4th degree or higher, right? And when I look back up here, it is a 4th degree polynomial. So I can see why I have 1, 2, 3, 4 solutions possible. I'm not done because I was supposed to I found the possible zeros, and then I found all the actual zeros, and some of them are irrational because the square root of 3 is irrational. And then it says graph the function in Excel or on your calculator. I'm going to show you how to graph it using Google Sheets. And so I'm going to sort of split my screen a little so that I can show you that. I know my solutions, right? And so I want to see what the shape is and how it's going to look when I actually graph it. So I need to be looking at those numbers as possible values for my x's, but remember I need some numbers smaller. I might just start with a -3 and then go to a -2, -1. And remember, when you're using Sheets or Excel, you can select a couple cells, and Excel or the Sheets will look at the pattern of the numbers if you go to the bottom right and drag it down, and they'll just continue the pattern for you. Now, I do have two numbers that aren't showing on this list. Oh, a couple of numbers. I need to go all the way to 7. It looks like that was one of my solutions. So there we have up to 7. But I also have the square root of 3. So I'm wondering what the square root of 3 is equal to. So I'm going to just put it into Sheets to have it calculate for me. So I put in the equal sign first, and then the keyword for taking the square root is SQRT, and I can do parenthesis, and then I want to give it the value, so I want it to take the square root of 3. And remember, we had the positive or negative square root of 3 as two of our solutions, so now I can see 1.732050, whatever, that's my entire square root of 3, and I have it in the positive and negative version, and it is 1.73, so it's between 1 and 2. So if I add a line here, I can insert one, and I can put in this actual square root of 3, so Control X maybe, and then Control V to paste. And so now I have the square root of 3 in between 1 and 2 where it belongs numerically in order, and then I also need the negative square root of 3. So that's going to be the same value, but on the negative side. So this one will be equals negative, and then SQRT for square root, parentheses 3, parentheses, and then push enter. So there's my negative 1.73, and it is between -1 and -2. So I have my x's all set up. I'm starting one number smaller than my 0 that I found, the -2, and then I have my other zeros showing x-intercepts, right? And I also want to know what my y-intercept is, so I did put 0 as one of the values here. This is going to give me a lot of points, but I want to plug in that formula now, so I'm going to slide up to where the formula is. And again, start with equals. Start with equals, and then I need to start putting in that formula. It begins with x to the 4th. These are my x's in this column, and so the first one I want it to calculate is going to be that -3, and it needs to go to the 4th power, so I use the caret and then the 4, and then I need to subtract 5 times, and then it's going to be that x again to the 3rd power this time, and then subtract 17, and I'm finding all this from right here on my function line. So it should look kind of similar, but I'm going to see a1 instead of x, and then a caret instead of an exponent. Okay, so that's how my function should look. So far x to the 4th minus 5x cubed. This is x to the 4th minus 5x cubed. And I have minus 17. Now I have to put in the times, and then click on my x again, and this time it has to go to the 2nd power, and then plus 15x is my next term, so plus 15 times, click on my x, and then the last part is plus 42, so plus 42, and then I'll push enter. So I get 60 as the value. We could double check that, but there are 3 or 4 numbers that I know should come out to 0, so I'm really going to watch those, and if they come to 0, I know that my equation is done properly. So I'm going to go to the right hand corner of that cell that I put the calculation into, and go to the right hand corner. See how my cursor changes to a little skinny plus, and I'm going to drag it down all the way down to where I have the 7 and let go. And what it's doing now is calculating using this formula, but every time it goes down a line, it uses the next x down. So in the first position, you can see it's A1 everywhere. And when I push enter, When I go down to the next cell, you can see now it's A2 everywhere. And so it's using this cell, the -2. And when I go down one more, then it's A3. So every time I pull where I drag that formula down, it adjusted where it looked for my X. So it's looking for a different X every time. And so each of these are my inputs and then all of my outputs. And you can see the zeros are showing up where I thought they should, right here and here. And if I look at the formula and I think when I plug in 0 for x, then all of these terms at the start are going to evaluate to 0. And I'll just have a plus 42, and we can verify that here, that I have 0 and a plus 42 for my y part. So this is my y-intercept. And I have a bunch of big negative numbers here, and then it jumps back up to 0, which is pretty interesting. So what I want to do is see what this looks like on a graph. So I'm going to select my data and then say insert, and I want a chart, and it's giving me options for my chart. I probably want to go with this dot chart here, and I would want to customize a little bit and say this is f of x at a minimum, and maybe even put in this function, but it really looks bad with the way we can type on the keyboard. So my horizontal axis, that's going to be the x values, and I can switch to left vertical, that's going to be the f of x or the output values. I can fit a trend line, and we know this one is polynomial, so I may as well make it polynomial, and degree we know is 4, so I may as well follow that as well, so it'll show the actual function. I can show the r squared, it should be a 1 because I calculated using the function to find all those. And I can also show the equation on my chart. And when I have all of those done, then I'll just do insert, and I can see that my polynomial should look like this. Okay, I can see my 2 zeros here. And another 0 here, and I can see it dips way down low, see the -300, and then it shoots back up right after 6. So it shoots up to 0 for 7, and then it's shooting straight up after that. So remember, you can copy this by using the snipping tool. If that's always my fallback, so I want to show you that for sure. So I can copy that much of it, or if I prefer, if I make this larger, I can see that I have the equation showing over here, and I could take this, click somewhere on the graph. I clicked on the outside line and then click move and resize, and that's going to let me shrink down my graph somewhat so that I can see the entire equation on one line, which is always nice. And it's showing me that r squared is a 1 because it's a perfect fit because I graphed it from a polynomial of degree 4. So I might want to just copy this. And again, I'll use snipping tool because I know it's going to work every time. And I just select the area that I want to copy. And now that's in my buffer, so I can go into a doc file or a Word file, either one, and I can just do Control V or use the paste function, and I can shrink it down a little so it's not so giant. And there we can see what the function is supposed to look like. Remember, it should have arrows on both ends of the line, and I can see the equation for it here. So that's a really nice graph. Back in our work, so I did that, and it says it should help you identify reasonable attempts at finding the rational roots. I could attach my graph. I don't find the graphing part very helpful because you kind of have to know what region your roots are in already. But since I was able to just look at it, let me show that one more time. Look at the graphed version of it, it did verify for me that I did get the correct intercepts and then also what the shape of my graph is. It is x to the 4th, so we expect both ends to go up, and on this graph it does look like that's what's happening. So that's how you would graph using Docs or Excel. And then it says factor f of x into linear factors. Well, I did that as part of what I was doing when I solved. And so here are my linear factors and there are my solutions. So I could just write those down to be really clear about which is which. Okay, that's it. So we have a polynomial that we were able to factor using synthetic method, and then we solved one little chunk of it to make sure that we had linear factors, and then we could write the solutions. And as well, we went into Google Sheets and created a graph of that function using the actual function itself. So we entered in x values. I had to type in the function one time and then drag it down from the right side to get the values for all of the other x values. I put in the square root of 3, both in its positive and its negative form, because I knew that those two were also intercepts. And so we're showing each of them on the graph. And you can see the 1, 2, 3, 4 intercepts that we have.